job. Sounds very dangerous.
Is that Homer Simpson?
It is Homer Simpson indeed. So if I was to ask you guys to build this, okay, the first statement form would be what, guys, for this? P and Q, right? I mean, it's so obvious, P and Q. And the conclusion is, therefore, Q. So all we have to do is just see if one of the basic rules of inference decides to fit that, okay? If I look at my basic rules of inference, I believe that specialization may be the one that fits that, okay? And if you guys wanted to prove specialization, you could use a truth table to do so, okay? So you would say that, once again, this is valid by specialization. Okay, so, any questions about being able to verify either by truth table or by using these basic rules of inference if an argument form is going to be valid or invalid? Okay. If it, by the way, if it doesn't fit one of the forms up here, just assume that it's not going to be valid. Okay, because I'm not going to give you guys anything that's not on this. If you ever needed to in real life check it, you could just use a truth table and verify that.
So the division in the case is an outlier for this?
Yes, sir. That's correct. All right. Other questions, guys, I can answer before we move on to the last stuff here? Okay. Now, I want you guys to take a look at the very last argument form that we have, or the last couple here. If I were to ask you guys to prove this by truth table, which you could, okay, what would be the problem if I asked you to prove this by truth table?
4, 5 variables.
5 variables, which means how many rows?
32.
32, which means pain in the ass, right? Pain, like absolutely. No way, okay? You guys don't want to sit there and use 32 rows. You don't even want to use 8 rows if you can. So what we're going to do is, instead of a truth table, all these basic rules of inference, we are going to build the basic rules of inference from what's given, okay? So you guys have that sheet, okay? I don't have it, well, I can't look back and forth, but what we're going to do, guys, is we're just going to pick apart the premises to get to the conclusion, okay? So basically, if you guys were thinking of a process for this, okay? You're going to use the premises to build the basic rules of inference. And remember, guys, the basic rules of inference are all valid. Please, sir.
In this case, does T stand for true? Or
I was actually just going to alliterate that. That's an excellent question. In this problem, T is its own unique variable. It is not a tautology in this case. Okay, so I should probably use capital T's from now on. Okay, so I apologize. I'll make sure, like if it's a homework problem, that I'll make sure that there's no T's in there to try to confuse you guys. I'll try to use different letters, like gammas or something weird like that. All right, let's see how we're going to do this, okay? So, the first thing I think we should do is, let's start with the most simplistic thing that we have in this, okay? Now remember, you can't use the conclusion, okay? I mean, you could, but you'd be wrong, okay? So, this is what we're trying to get to, okay? So, don't just jump to the not Q. Well, that didn't help, did it? Oh, stupid computer. There we go, okay. So, I want to pick on the easiest thing that I have, and the easiest thing I have is not T, right? It's the most simplistic thing to start with. There's only one other statement that has the T in it. That's P implies T. So let's see if we can build something that looks like one of the argument forms. Okay, so. Does anybody think they might be able to build one of the basic rules of inference from just using the not T and the P implies T? So, Donnie, what do you think, sir? Modus ponens, or modus tollens, right, sir? Okay. So, if this is step 1, you would have P implies T, right, guys? And then you have not T, okay? As a result of modus tollens, what is the output then for this?
Not P.
Not P, right? Guys, take a look at your modus tollens. P implies T. If you have the negation of the conclusion, that gives you the negation of the antecedent, okay? So this is going to be not P, okay? So this is just your modus tollens, okay? Remember, these are all valid. So once you get to this, you're allowed to use this as many times as you want in the problem, okay? So now what we're going to do is we're going to get rid of the not T, okay? We don't need this anymore. We're going to get rid of the P implies T as well, okay? So those are off the table. We don't need those arguments anymore, okay? Now what I need to do is I need to find something with the not P in it.
I got a question.
Sure.
You can start anywhere in the argument, you don't have to follow sequence or something?
No, sir. They do not have to follow sequence, okay?
Okay.
It's just like, you can just rearrange them however you want to do it, okay?
Gotcha.
So just because it was the third and fourth one down, start wherever you want, okay? All right, so I have not P, okay? Well, it looks like the only thing that's up here that has a P in it is either not P and R, or not P or Q, okay? So I either have to use something to get me here, or something to get me here. Okay? Does anybody think they might have one of the rules of inference, and you have a 1 in 8 shot that could help us? Yeah, this one's kind of sneaky, okay? If I have not P, and that's from step 1, couldn't I have not P or anything else, okay? Let's play peekaboo game, okay? I have black marker, or I have $1 million behind my back. I'm not lying to you, right? I have not P, or something else, right? Now what's the or something else that we want? Or Q, right guys? We want to build that statement, and that's by generalization. Take a look at your rules, okay? If you can build something with an or, you can't build an and, but you can build or, okay? So this would be not P or Q by generalization. Does that make sense, guys? Sometimes you have to build a statement, and you can use whatever or you want. In this case, Q helps us out. Okay? And then, by the way, this is a therefore. Sorry about that. Okay. Step 3. Okay. We can use not P or Q. Okay. So, wouldn't it seem likely that we should probably use this? Because we already have not P or Q implies R. So we have not P or Q implies R. Didn't we just verify not P or Q is valid, okay, in the previous step? So, we have not P or Q from step 2. So, what can we conclude based on one of the 8 rules of inference, and what's the rule that we would utilize?
Not P or Q.
So we have antecedent, right? And then the previous statement has antecedent implies conclusion. So, anybody think they might see something that can help us? Give you a hint. It rhymes with modus. Oh, go ahead, sir.
Can you use modus ponens?
You can, yes, sir. Excellent. Okay, guys, take a look at modus ponens. It says antecedent implies conclusion. P implies Q. Think of P or Q, or not P or Q, as the antecedent. Think of R as the conclusion. Well, if you have antecedent implies conclusion, if you have antecedent, then you have the conclusion. By exactly correct, sir, modus ponens. Okay? So, like I said, the P and the Q, they're just placeholders. Okay? They can be whatever they want. In fact, they could be a statement form, as long as it fits the form of this. Okay? So, does that make sense, guys, so far? Any questions? Okay, again, this is another one of those tough things, okay? So, I'm going to get rid of the first. Okay, we're almost done with this, by the way. Okay. Now I have R. Okay. So, doesn't it seem reasonable for me to be able to say, from step number 1, I have not P. From step number 3, I have R. So, for step 4, I have not P, and I have R. Not P is from step 1, and then R is from step 3. So if I have not P, if I have R, what does that mean that I have? Not P and R, right guys? Okay? It's just like this. If I have black marker and I have blue marker, I have black marker and blue marker. Okay? It's the same thing up here. So, therefore, this would be not P and R. And what's the rule that says if you have two statements, you can conjoin them? Conjunction, right? It's almost like I was trying to give you guys a hint with that. So, conjunction. Nice. Yeah, I know we've only got 3 minutes left, and you guys care less about this at this point. But regardless. Okay. Does this make sense, guys? Any questions so far? We're almost done. Okay. Well, now we can use the 5th line for step 5. Okay. So for step 5, we're given that not P and R implies not S. We have not P and R from step number 4. What can we say as a result of that then? What's the conclusion from that and why? Not S. And how come, sir?
Because P and R implies not S. So
And we have P and R, which is the, yeah. So we have not S. Which rule is that, guys? Modus ponens. Nice. Good job. In fact, it's the same exact structure that we just saw in step number 3. Okay. All right. Well, I think we're done with this because now, our final step, the last, oh, sorry, I meant to cross this out because we're done with it. The last possible premise we have is S or not Q. From step 5, I was told that we have not S. So what does that tell me must be left over? And why? So it says I have either blue marker or black marker. I don't have black marker or blue marker, so then I have black marker. Go ahead.
It would be modus tollens because of the, it would be Q.
It would be not Q. And unfortunately, it's not modus tollens, Andre. Close, okay? Because it doesn't have an implies in there.
Oh.
Okay. Try something else. Maybe something that rhymes with elimination. Go ahead, sir.
Take away the M.
Oh, yeah, elimination.
And then you
Nice.
change the letters.
Sorry, I'm not good with words and all that shit. So, yeah, it's the elimination one. Okay, very nicely done, sir. All right. All right. So, yeah, I think this and the Boolean algebra stuff, and by the way, we're done because we got to the conclusion. I think this and the Boolean algebra stuff is going to be the toughest stuff. Okay. So, I know we're out of time, okay? For next class, do every problem that's on the assignment except for the very last 2, because we didn't go through 2 examples of this, and I want to go through those 2 examples. So just hand in, I think it's problems 1 through 10. Omit number 11 for now. We're going to finish those up, and you guys can just hand them in on, I guess, on Monday the following. Okay? So remember, guys, we're not coming here Monday, right? Because it's Labor Day. If you do show up, you're going to be the only people there.
I'm lost. Which one do you want us to do?
I'll post it on Blackboard, but assignment 1, do every problem except for the last 2 problems, okay? The
Okay.
very last 2. Because they're just like this, and I want to make sure we go through 2 examples.
Okay.
All right, guys, if you have questions, email me so I can help you out. I will see you in a week, hopefully, God willing.
So is assignment 1 not due